Welcome to Infracoders July 25th. I'd like to thank Australia Post for hosting us. It's quite a big turnout. Normally in July we have everyone hibernating, so this is really good. A few housekeeping things. The bathrooms, if you go out towards the lobby and head down the hall and to your right, that's what they are. And also for safety reasons, if you hear beep beep, get ready for an evacuation maybe. And if you hear the whoop whoop siren, just follow the little green man and you'll get evacuated of the building. And Treasury Gardens is our assembly point. That's all the housekeeping stuff. I'd like to introduce Cameron. He's going to give us a little bit of a rundown on Australia Post.
Thank you. So we're normally a alcohol-free building, and the great thing is you can bring alcohol in if you've got external guests. So tonight is just an elaborate ruse to have a drink at work. So thank you. That's it from me. Look, a little bit about our story. So we're the digital delivery centre is the area that I'm in. A lot of the activity around continuous integration is happening there. And since we started, it's now gone much broader in the organisation. We've had some amazing work done by some people in the room here to get public cloud, private cloud capability, and new data centres and so on, which is really sort of building the underpinnings of what we need to make this work. And if I think back to when we started, I like this picture because it sort of reminds me of how projects kind of operate. So when I came in, very project-based environment, and what you get from projects is a bunch of people coming together to deliver an outcome. And because of the time it takes to get environments up and get sort of work through the pipe, it sort of drives you to more of a waterfall approach to work. So if it takes you 6 weeks to get an environment, you better make damn sure you build the environment right. If it takes you sort of 2 or 3 days to do a deployment, you want to make sure you don't do many of those. And what it drives you is back to sort of lots of upfront requirements gathering so that you know exactly what you're going to build, and it tends towards this sort of waterfall process. But what you end up with is at the end of that project you deliver, and the moment you want to make a change, you realise actually you haven't delivered this sort of capability to make ongoing change. You've just delivered an outcome through that project. So when we came in, we said, look, what we want to really do. So we want the ability to continuously pump work through a pipeline, and that factory that we put it through just gets faster and faster and more efficient. So it causes you to sort of look at the way you're working and think, well, if we're going to build a factory, what are the fundamental underpinnings that we need for that? And you quickly get to things like automation, continuous delivery, moving to cloud, and so on, because that gives you the flexibility and speed that you need. And so this picture, I think it was kind of really short there, I think it was Volkswagen or Audi. It kind of symbolises how we used to work, which was everything very manual, nothing repetitive. You had lots of people involved in anything you wanted to do. And we've made some great shifts now to, many of you have been familiar with it, building stacks in sort of 6 to 7 minutes, highly repeatable, very secure. And it enables us, the ultimate goal is it just enables us to deliver change to customers at a speed that we just couldn't even think of at the start of this journey. So I'm really delivering good results. I was reflecting with someone before that I guess the downside of what we do is that when you do it really well, it doesn't get noticed. Sort of like when your Wi-Fi works, stop and say, isn't it amazing how fast the Wi-Fi is? It's just always on, it's always there, it's always available. And one of the things here is that when this works, it doesn't get called out. And we need to do a better job of calling out how hard this would have been if we went the old way and so on. We're sort of working on it now, but it is an amazing capability. And if I look at where we've moved to today, so we've grown from, I think around 40 people at the start 3 years ago. So in the digital space, we've got around 300 sort of business IT mixed people, organised into agile teams, around 17 now, 3 tribes, thanks Spotify for some terminology. And what we support, last year we moved all of our applications, all our digital applications, from a sort of more classic sort of virtual server-based to AWS. So we're all in the cloud now. Back end still not, but front end is. 2.5, I think we're well above that now. Registered users, about 144 million visits per year. It was an additional stat. I think it's 90% of the visits are going through Amazon, of those 144. So pretty significant sort of shift. So I'll leave it there. What I love is that some of the capability we've built has only been possible by a lot of the sharing that goes on in open source communities and things like this. So, we're really happy to support today. This is about encouraging more sharing, and collectively we'll advance the capability that sits here in Australia, which will help, I guess, the competitiveness of you as individuals and also the country and economy as a whole. So, thank you. That's it from me. Cool. Thank you. Cheers.
So our first speaker has flown all the way from the Blue Mountains in Sydney. Lindsay Holwood, he's going to be talking about Coco, which sort of touches on RRD tool and CollectD. If you've ever used those in vain, this might be interesting for you.
Hopefully it'll be interesting in general. Yeah, if you've never used like CollectD or RRD tool, you can just get it out. Right?
Please don't.
I was going to preface the talk with I came in here for 5 minutes while the pizzas were delivered and I came back out and there was nothing left. So I haven't eaten since before I got on the plane, so I'm going to try and hype myself up with a little bit of chocolate. So you're all in for a little bit of a wild ride tonight. We'll try and keep it nice and quick and fun. So I'm going to be talking a little bit about Coco, which is a tool that I've been working on for the last sort of 6 months, and have recently open sourced in the last week alone. So a little bit of background about why you might find Coco interesting. Who here has used CollectD or even has heard of it at all? Okay, so that's maybe half the people in the room. So for everyone else, CollectD is a lightweight system statistics collection data. It is plugin based, so it's mostly focused around getting statistics out of things that are happening on Unix machines. But there is a port of it that actually works on Windows as well. With the plugins, there are a lot of different plugins. This is actually, I think it's 2 releases behind what's current. I'm seeing more plugins available now. So these plugins that you can see here, all of these are re-plugins to get information out of things like OpenVPN, NTP, all the different things that you can see there, right? And there are a bunch of these other plugins as well for writing the data. So you're collecting the data from the re-plugins, you're writing the data out of the write plugins. So these red ones are here. There's also a bunch of bindings for other programming languages. So you can write native plugins that do either reading or writing. So it's a very, very flexible, extensible system for collecting metrics, doing interesting stuff with them, and then forwarding them on. The other really interesting thing about CollectD as well is that it's network aware. So it's not just about collecting the metrics and then just storing them on the local system. You want to collect them and then dispatch them and get rid of them as quickly as you possibly can in some sort of central aggregation point. So, RRD tool. Who here has used or even heard of RRD tool? Okay, so there's a few more people than heard about CollectD. So, RRD tool is definitely old school. It's an on-disk time series data storage. And you might be thinking, well, RRD tool, isn't that bad? Like, isn't that the reason that we have things like OpenTSDB and InfluxDB and Graphite and whatnot? Well, I sort of like to think of RRD tool as being like heritage software, not legacy software, like, has a long, proud history, and it works in a lot of different places. So there are a bunch of really good things about RRD tool, actually. Things that a lot of other tools that have tried to replace it don't actually do all that particularly well. So it's an on-disk format, so you basically have a file per metrics that you're storing. It's very simple, very easy to reason about. It's also very fast and space efficient because it's binary. So all the data that is writing onto the disk, it's writing in a binary format, and it's doing that in quite a quick way as well. It has a proven track record. RRD tool has been around since, who knows how long RRD tool has been around actually?
Forever.
Yeah, basically. Okay. Since I think 97 or 96, 97 originally came out of the MRTG project, so it's been around for a while. If you've ever done any sort of network operations work, you've certainly come into contact with it. It's been around for a very, very long time, and it works quite well. It's also scalable as well, at least on a local scale with tools like RRD CacheD, which basically allow you to batch up the writes so you don't have like an I/O hell situation where you're doing lots of random writes to lots of different files. That's sort of the disadvantage here of this on disk format. With lots of individual files, you have lots of seeking around the file system. So if you use something like RD cached here, it becomes very easy to serialize those writes out so that you don't obliterate the underlying storage. So try and think of RD tool rather than being a bad thing. It's sort of like the SQLite of time series databases, right? So the typical way that you might use something like collectd and RD tool together is like this. So if you're starting out small, you have a bunch of collectd clients here, which are running on your individual instances or servers. And they're all sending all of their metrics through to this collectd server over here. Not complicated at all. And then you're backing the collectd server with something like RD tool here. Right. That works very, very well when you're simple and you're starting out and you don't have that many complicated requirements. But as soon as you start relying on this system, Adrian Cockcroft has got this fantastic action here that all monitoring systems should try and obey, which is the monitoring systems by definition need to be more available and scalable than the systems that they're actually monitoring. So the problem that you see with previous approaches is that it's all going into a single place, right? So it's not particularly available. So what you might try and do to start scaling that out is you might use something like Samplicator, which is like a UDP packet processing tool. You can basically mirror streams of UDP packets that are coming in and then forward them onto multiple locations. So you end up with a situation like this where you have a bunch of different collectd servers that are all storing their data with RD tool. They all have it. They all have their own copy, full copy of the data. This heritage software. There aren't just good things about it, there are also a bunch of really crap things about it. Replacement that are trying to do a similar sort of thing. So the first really big problem with RD tool is that it pre-allocates all the storage that it's going to need ahead of time. So if you say that I'm writing data into a file every 10 seconds, and I'm going to hold on to, say, 2 weeks worth of data, it's going to pre-allocate all that space that it's going to need ahead of time. So when it comes to actually writing in the data, it basically seeks to a position in the file, writes the data in, and just continues over and over and over until it gets to the very end of the file, and then it loops back to the beginning. So that's obviously very storage inefficient, right? Also doesn't give you a lot of granularity here. And what you tend to find is that you end up sort of doing crazy things to actually scale your RD infrastructure to keep it going. So, you know, you just throw huge amounts of storage. That storage isn't necessarily cheap either. It's sort of difficult to justify to the business because it's like, well, I'm pre-allocating all the storage here because I'm going to need it, but I'm not actually using it yet. So, you know, it's a bit of a, it's not the best position to be in, you know, as an engineer, try and make that sort of argument. The other problem with RD tool as well is that it lacks distribution. Like I was saying before, it's like the SQLite time series databases. It means that the data, there's no sort of way of distributing it across lots of different nodes here. So as I said before, you'll end up with a situation where you have identical data, all these different metrics that you're getting from different collectd clients going into all of your different storage nodes. So that's also, it's a double inefficiency on top of that, all that pre-allocation that you've got. So this is what Cocoa is actually trying to solve here. It's trying to solve the distribution problem, and we sort of try and get at the pre-allocation problem a little bit as well. So Cocoa has a very, very simple aim. It's trying to help you scale up RD tool and collectd. Nothing complicated at all. The thing that we found is that there's quite a big gap between just starting out with collectd and getting a bunch of graphs up and, you know, getting really good value out of that, and then having to scale up your monitoring systems to deal with very large numbers of systems. You know, there's a good technology that services the small end of the scale and really good technology at the big end of the scale, and there's this massive gulf in between. So what Cocoa is trying to do is sort of bridge that gap a little bit, not completely fill it, but, you know, try and bridge that gap. So there are two parts to Cocoa. Firstly, there's Cocoa, which is a collectd packet sharder, and secondly, there's Noodle, which is an RD tool metric fetcher. So it's no good to just write out all these metrics to all these different storage nodes because you actually need to be able to get the data back to do something interesting with it. So the way that it works is actually very, very simple. So you have a bunch of these different storage nodes, and these are all running collectd and RD tool, and you have Cocoa and you have Noodle sitting in front, and they're just running in parallel. They can be on the same instance or they can be on different instances. It's really up to you how you do it. So you have a bunch of collectd packets that are then coming into Cocoa, and then Cocoa is doing this consistent hashing of all those metrics that are coming through and then distributing it to a bunch of these storage nodes. And then with Noodle, you have a HTTP request for metrics that you want to get back out. and Noodle will make a request to those storage nodes and retrieve those metrics from them. So not particularly complicated, but conceptually that's all that we're trying to do here with Cocoa. So you're probably asking, okay, that sounds great, but how do I actually use it? This is probably going to get quite complicated. Well, it's not actually that difficult at all. We ship binary releases of Cocoa. Cocoa is written in Go, so it's fantastic for, for deployability across scalable infrastructure. So you download the tuple, you decompress it, you go into the directory, blah, blah, blah. We ship a bunch of sample configuration here, so you copy that in place, and then you just run it. That's it. The configuration will actually just work completely out of the box. Obviously, you probably want to change a few things in there about where you're actually sending the metrics to, but it just works out of the box. And then from here, you might use something like collectDTG, which is the collected traffic generator. You basically say, pump a whole bunch of fake metrics into Cocoa and see how it actually handles those metrics that you're passing into it. And so here we're saying that we're passing in about, or we're generating fake metrics for about 1,500 hosts, and there are about 50 metrics per host. So you feed that into Cocoa, and Cocoa will handle distributing that to lots of different storage nodes behind the scenes. And then to get that, get those metrics back out again, you run Noodle on the same configuration file, and you do a curl request to it, and then you get back a bunch of data that looks like this, including a bunch of metadata as well about how the request is actually routed off to these storage nodes behind the scenes. Not complicated at all. So I keep saying not complicated, but how does it actually work behind the scenes? Well, a little bit of prior knowledge first. So who here is actually familiar with the collecting network protocol, like the packet format? There's 1, 2, 3 people, okay. And they're all people that I've worked with. So everybody else in the room. With a collectD packet, basically what collectD on the agents will do, the collectD clients will do, it'll buffer up a bunch of different samples that need to be sent out into as large a packet as it could possibly get, so it's efficient. And you've got these multiple samples here within the collectD packet payload. And within each individual sample, you've got these fields here. You've got timestamp, interval, host name, plugin, and type. Right? So we use the host name here to do the hashing. So what Cocoa is doing when it gets a metric is that when it's getting a collectD packet, it's listening out for them. It's then turning that packet payload into multiple individual samples. And it's passing them to a filter. Now, the filter then constructs a metric name, so we can use plain old regex on that to do filtering of the metrics that are coming in that you might just want to drop on the floor. So we found in our experience of running very, very large, scalable monitoring metric infrastructure, it's much easier to discard the data ahead of time than to store off the disk and then have some sort of batch process that's constantly trying to clean it up. We've had a lot of problems with that in the past, so we just specifically designed this filter functionality into Cocoa so that you can drop metrics that you know that you just really don't care about, but you don't necessarily have the control to change on the client, on the collected clients out in the wild. So then once things get through the filter, then they're passed through the send function, and the send function is just hashing on the sample hosting. So in this particular case, the metric that's come in, or the sample that we're dealing with here has been hashed to Alice, and then it's going to distribute that packet to, distribute that sample to a storage node named Alice. Now, Noodle is conceptually, it's very simple. So it works pretty much in the same way, just less filtering involved. It's basically a proxy that works out where the request should be routed based on this consistent hash. So you have a fetch, it tries to do a lookup against this consistent hash, and in this particular case, it's going to Alice as well for the same metric. So that's it. But you're probably still asking the question, well, Lindsay sort of glazed over that RRD tool is perhaps a little bit inefficient. Don't we want more efficiency out of our monitoring metric storage so that we're not pre-allocating all the space ahead of time? That's a very, very good point. So one of the things that we tried to do in Cocoa is we can't completely solve that problem with RRD because that's sort of baked in fundamentally into the way the RRD tool works. But you can run parallel infrastructure that holds onto the data at different resolutions for different time periods. So we sort of bake that into Cocoa out of the box. So again with Cocoa, we sort of solved this distribution problem here, and now we're going to try and tackle this pre-allocation storage problem. And typically, whenever you try and do anything like this with collecting RRD tool, this is the answer that you get. So this is sort of the first time we've actually been able to try and solve this problem. And we solve it with a concept that we call tiers. So no tiers, just strings. So you have a bunch of tiers that live in your config file here. So we're saying here that we've got 2 tiers, short-term and a mid-term. There are a bunch of different hosts on these. Now, I sort of simplified a little bit what the send function is actually doing. So when you have a metric, a sample that comes through here to the send function, it then loads up the consistent hash to that short-term tier, and then it does dispatch of that to, say, Alice in this particular case. And then it loads in another tier, the mid-term tier, and it will apply the same consistent hash, and may get hashed to a different host over here, to say E, for example. So you can define an arbitrary number of tiers that you want to have with different retention policies. So a good example of that is that, say, for long-term retention, you want to store it across a larger number of cheaper instances that have got a lot of cheap storage attached to them. Because that's more for sort of historical graphs that you want to go back in time and have a look at, but very, very rarely. So you don't care as much about the responsiveness of getting the data back out again. But say with a and that might be like more of a long-term or a mid-term tier. Then a short-term tier is maybe something that's SSD backed, or you're using RAM disks or something like that, a Temperfest. And you want very, very quick responsive retrieval of those metrics because you're going to be running monitoring checks across those. But those, that the retention that you've got there is actually quite small. It's maybe only like a day's worth of data, maybe a week's worth at most. So you don't want to hold on to the data for very long, but you need to be able to get at it very, very quickly. So with Cocoa and Noodle here, it will handle distributing that data and also retrieving it for you. So to finish up, how do you actually operationalize this? This sounds all particularly great, but how do you actually make this sort of stuff work in production? So when you get the release of Cocoa, we ship a bunch of things here to help you operationalize it. Firstly, we ship a bunch of upstart configuration, which you can adapt to SysD if you need to. There's also a bunch of collectee configuration here for getting metrics out of Cocoa and Noodle about how they're actually performing. So probably can't see the stuff at the back. In fact, probably the people at the front probably can't see it all that well either. But we ship an absolute boatload of documentation around all the different metrics that we collect internally within Cocoa and Noodle to find out how it's actually performing and behaving. We've had this operationalized for a couple of months now. We're pushing a lot of metrics through it. So we know the pain points. We've instrumented all this sort of stuff for you already. So an example of that here is this is the send throughput for each individual target. So there's a bunch of storage targets here that we're writing data to. And with this graph that we have here, we're collecting the data from within Cocoa about how the package is being distributed. We're able to use the data that we are collecting from within Cocoa to help determine that it's actually CPU contention on the host where Cocoa is running. So we can see that when there are other tasks that are holding the CPU, the overall send throughput of Cocoa will drop off. So we've tried and tested this. We know that it works quite well. The other interesting thing that we do here is we ship 2 other monitoring checks with Cocoa. So we ship check anomalous Cocoa errors and check anomalous Cocoa sends. So they're just using a very simple statistical test called the Komolder or Smirnov test. And they basically sample that data, the same data that you've seen in the previous graph, and it's working out if the distribution of that data is changing over time. So the nice thing about something like Cocoa is that it's fairly, the volume of data that's flowing through it all the time is fairly consistent. So you can apply these very simple statistical tests against those to actually work out if the flow of metrics is dropping off or speeding up or those sort of things. So this is stuff that we've been running in production, and we know that it works. So how do you get it? Well, find it on GitHub there, bulletproof network/Cocoa. Do we have any questions? Yes.
Have you tried with your RD data files? Have you tried using VTRFS with LZO compression to both improve performance and reduce the disk I/O?
I personally have not, but I've seen other people do it. And the first problem is ButterFS, but if you ignore that, then yeah, I've heard really good things about it.
Is that ButterFS on an ancient kernel like CentOS 6 sort of thing?
Yeah, absolutely.
Okay.
Yeah, like more modern versions of ButterFS, pretty decent. Yeah, doing it with LZO is a great way of getting those gains ahead
The
of
reason I
time.
asked that is really quickly is we're using ButterFS with much more modern kernel and things like that work really, really well as long as you're not using something ancient like CentOS 6.
Right. So if you look at other time series databases like InfluxDB, one of the real store on disk, but they're also snappy compressing it whenever they're reading and writing the data. So Snappy's it's pretty fast and a similar sort of compression ratio to LZO. So yeah, that's the way the data get their space gains. Actually look at the amount of space that, for the same retention period of data compared to RRD tool, it's only about 20% better. Yes, there's some other questions. Yes?
How do you handle node replacement?
Yeah, so that's a really good question. How do you handle node replacement? So we have a general rule that you don't do any resizes of the ring, because with the consistent hashing algorithm that we're using, the percentage of nodes that you change in the ring equals the percentage of the number of the percentage of metrics that get redistributed across the ring. So let's say, to put that in more concrete terms, say I have 10 nodes that I'm storing metrics on, and I remove 2 of them, and I put in another 2 to replace them. Then it means that you're going to get 20% of all your metrics redistributed across your circle. So that becomes an interesting problem to try and reconstruct the data as well, because then you've got metrics that lived up to a point on one host and then now living someplace else. So you've got to try and glue that data up. So the short answer to your very mischievous question is that you should absolutely not change anything in the server. That said, though, there are a bunch of ways that you can sort of handle that problem. So internally, actually, within Cocoa, I really simplified the way that the consistent hash works, but we actually maintain a shadow map that gives us more even distributions of the metrics. So you can apply a similar sort of approach where you use names rather than IP addresses that you've seen in metrics too. And so if you need to swap out a particular storage node, yeah, as long as you keep the name the same, then you should be fine. Our recommendation for growing stuff over time is that if it's a short enough retention period that you've got, then just fire up another storage tier and let it backfill all the data and then get rid of the old hosts. If you've got a larger, obviously that doesn't make sense. Like say you're retaining data for a year or 2 years, you can't go, well, run this parallel infrastructure for a whole 2 years before we can get more storage in it. So that's a complicated problem, and if you want to talk about it afterwards, kind of fun. Yes, Justin.
I assume that what you clarified, where you could actually specify some frequency over time. Like for instance, for an organized state, you can get a frequency of once a second, and then produce that every minute, and then every 5 minutes, and then every hour, for instance,
Yes.
So you call that up. Can you do the same kind of thing with Cocoa, or do you have to just allocate a lot more storage for everything that is older than 2 days?
Yeah, I see what you're getting at. So the way that we would solve that problem is that each individual storage tier for your metrics has its own retention settings there. So we currently do that, and we've got different tiers with different retention settings. The thing that we're about to add into Noodle actually is that it will basically have, in the tier definition you were seeing earlier, it'll have some data encoded in there about the duration of time that each of those tiers is responsible for. So when it gets a request for a particular metric over a particular time span, it'll automatically determine the tier that's going to have that data at the highest resolution, proxy the request to that tier, and then return the data. So yeah, that's
But that means that historically, do you keep one event per second on historical stuff that happened months ago, for instance?
Oh, right. So just sort of a general approach to how long do I hold onto my time series data for?
Yeah. Like, do you just start creating average statistically, or just applying some very, very complex transformation to get a better average, or not quite dismissing outliers or something like that?
Yeah, sure. I guess like any answer in tech, the answer is it depends. But that said, if you're looking at doing smarter averaging and downsampling of data over time, there's some good stuff in RD as it works right now. But if you want to do like aggregations across classes and things like that, have a look at a tool like Riemann. So you can take the metrics out of collect feed it into Riemann. Let it do that. That's right. And then have Riemann push it back into something like Cocoa and collecting to do that for you.
Last question.
Stop with that.
So you alluded to data redundancy when you talked about redistribution. Can you talk about, describe a little bit how you would survive the loss of a node without losing data?
Yeah, so if you, very bluntly, if you lose a node within a storage tier, that's it. The data is gone, right? So the way that we do this internally at Bulletproof is that we use persistent storage with like EBSs. So we can just attach the EBS from the EC2 instance, so we can reattach it someplace else. But let's just say hypothetically, the EBS backplane disappears like it did a couple of years ago. Then my recommendation there is that you actually use a mix of different storage technologies for your different tiers. That's the great thing about Cocoa. It's not opinionated about that. It just provides a low-level primitive for distributing metrics on lots of different types of tiers. You can choose whatever the storage technology is you want to get them.
Let's say you're paranoid and you want to store 2 copies. Could Cocoa store, using a consistent hash, could you distribute the same metrics to 2 different tiers even though they have the same thing?
Yeah, absolutely. So that's core to what
yeah.
Cocoa is doing. Every single time a sample needs to be sent out, it will send it to, it'll dispatch it to every single tier. Yeah. Cool. Thank you very much.
Next up, we have Michael and Susie talking about empowering developers with self-service. You want the chocolate?
Just remember, I do actually know a bit about the collective market structure. Change that early on. Us can have a look at it. I don't know if we actually used it, but yeah, we had to build something. Yeah, we did build something past the packets. And basically said, yeah, to do this, we have to change things from that. We didn't change anything upstream. No. We didn't really price an experiment. There was stuff in terms of casing and it's a bit like that package stuff. Interesting. Yeah. I knew was that. So I was listening to the presentation with quality for how well he was communicating with people and stuff. And I thought, yeah, I thought it was very good. It's a complex topic. Yeah, it is.
Michael and Susie.
Yeah, sorry, Matt. We just changed the title a bit last moment. We're actually talking about collaboration through transparency. This is Susie. She's from Odyssey, and I'm Michael. And we both work as part of the Digital Delivery Centre Systems team here at Australia Post. So the DDC as a whole, we develop, operate, and manage all the consumer-facing digital applications here at Post. So lots of public-facing APIs, mainly developed in Java, and lots of front ends that pull all the experiences together. Script, as well as iOS and Android. Some of the application experiences that we provide include tracking your parcel, finding your local post office location, calculating your postage, or buying travel services such as insurance or money. Today, we're 100% in AWS, with 50% of our applications in production running on an application platform that is completely managed and provisioned by code. So technologies such as CloudFormation, Puppet, Pyra, and Python. But we did come from a long way back. 2 years ago, all our servers were managed by a managed service provider, and little to no configuration management or automation was used at the time. Along the journey, the question hasn't always been just about automation, but really about how we go about automating and scaling for the entire department. How we go about automating the provisioning, deployment, and management processes for our, at the time, 30-odd different applications, and how we can do this without significantly increasing the size of our systems team. So with 30-odd applications to support, infrastructure automation can be quite difficult when these applications have different behaviors and characteristics. For us, the focus has always been about development of standards. Standardizing the way we do application deployments, on how we respond to horizontal scaling activities, on how we update the underlying infrastructure, and how applications consume environmental configuration. Standardizing, the tool we're demonstrating today is a product of standardization, and it speeds up a lot of the processes we have within the DDC. And it wouldn't have been possible without operations, developers, and systems team coming together to agree on common approaches. Next, I'll hand over to Susie, who will show you what we've built.
So what we've built is a tool called Infracoders, which lets people view their infrastructure in a PaaS-like manner. So people can see their their infrastructure configuration and business details and stuff like that about their stacks. It also enables teams to update their infrastructure, so and their configuration, and deploy their applications. Not very good at presenting, sorry. Yeah, it also facilitates auditing because we have an API, and we also have a UI that's built on top of that. So Infracoders lives inside AWS, and it pulls information from EC2, CloudFormation, and RDS. It's built in AngularJS, running on Nginx, and sorry, the front end is, and back end is written in Python 2.7, running on Django REST framework. We use Photo to connect to AWS, and we use Celery for the backend tasks. And yeah, RabbitMQ is backend for Celery. And I guess no one can really be told what Infracoders is. You have to be shown. Experiencing technical. Wi-Fi's not working. Sorry, this view is kind of hard to. I guess. Yeah. Sorry about this. I spent the end of the last talk trying to get the Wi-Fi working, and it was working.
This happens with every live demo, don't worry.
Yeah. And I joined you guys.
You just did it.
Great. Okay. So this is Infracoders. A little bit better, zoomed out. Looks a lot better on a much higher resolution monitor, by the way. So as you can see about 260 to 270 stacks here across all three of OSPO's dev, test, and prod environments. It's not particularly helpful to find stuff like this, so we've got these quick filter buttons to find things in dev and test, or these are the load testing environments, these are the functional testing environments, but we can also filter within those by typing and search things. So I'm going to take a look at the dev community application running in functional testing. So this is the detailed view for it. You can see here we have it lists the applications running on the stack, the artifact versions. So these are like the jars and like the UI code and stuff. Then we have the automation code and config versions. That's the Puppet code version, and the Hierarch code version. We have them in separate repositories, so they're versioned separately, but we keep them in sync. Over here we have the cost code, which tells you which project's paying for it and the date it's created on. So even non-technical users can come in, find information, so they can figure out how much they're being billed to them. But we can also deep dive into the tiers. So this is the web tier, and this is the ELB endpoint, so you can go straight to it and see what it looks like. And we can also see they have two instances. They have these green boxes next to them that shows that they are in service in the load balancer. We can pick up, we can also see that they're running IP addresses when they were created. And it's the same for the app tier. And for databases, we can show you what your engine is and what your endpoint is. Doesn't just work for standard 3-tier ones. We also support other kinds of tiers, such as these. So arbitrary tiers also work. So now this is the actual risky part of the demo. Was I'm going to try and do an update to an Infraviewer stack using Infraviewer. Yeah, we're meta. Okay, so this is the dev Infraviewer stack, and I'll show you. Hopefully this will work. You can actually see the dev one is broken. This is because sorry, I don't know why the alignment's so bad. No. Okay, well, dev one's broken for some reason. There. This is because I actually messed up when I was doing the configuration, and I put the testing environment configuration into the dev one. So I'm going to have to correct that by updating the hierarchy so that it's actually running with the dev endpoint. I've already merged it into the integration branch, so it should be a pretty quick demo, hopefully. Log in. Okay, so the current version is 2.4.6. So I'm going to update so this is the higher code branch, yep, and this is the public code. And I'm going to cycle the instances. I'll explain what that means in a minute. So hit update, hit update. So this is a table that tells you, it breaks down what we're doing into steps. So if any of them fail, you know where it failed, and you can go and look at the logs for that particular task. Just to help explain stuff, I'm going to switch back to PowerPoint for a bit. So what's happening? First of all, we're going to do a cloud formation update stack, where we're going to change some cloud parameters. That's actually where we store the code, the automation code version, public version, and the higher version, and the application deployments. I'm not actually upgrading the code for Infraviewer in this, because that takes a while. We also could do any network changes here, but I'm not actually changing anything in the network, just changing an endpoint. So after it's done that, it's going to cycle the instances, which basically means that we're going to increase the autoscale group from 1 up to 3. We have to do 3 because there are 2 availability zones, and AWS picks at random which availability zone it's going to kill an instance from. So we create 1 in each so that it's guaranteed to kill the oldest one in each. So we'll only be left with 1 at the end of the scaling. Yeah. Okay, so after it's created the instances, it's going to bootstrap them, and it's going to run a puppet apply. Then it's going to deploy the applications. In this case, we're going to be deploying an AngularJS app on the web tier, and we're going to be deploying a Python wheel on the app tier. And once it's done that, we're going to wait until the ELB, the load balancer, says that both the instances are healthy, and then we're going to downscale back down to 1. So we're not paying for 3 instances, we're going to need 1. That's probably going to take about 10 minutes, so I figured I'd talk about some tricks that we had while building this. So the caching, we actually cache everything in AWS on our own API using our own data models. We partially cache because we do get about 10 requests per second on the API, but mostly we do it so we've got our own data models so that we can form our own analysis and so that we can build the UI looking the way we want it to. We update the database using atomic updates, but it's actually a bit more than that. So for instance, if we're going to cache the instances, we're going to go to AWS, we're going to pull back all the data about the instances, then we're going to transform the data model into what we need, and then we're going to wipe everything in the database table for instances and write the new instances on top of it. And so that we don't have any disparity in data. We don't have to try and merge what was there with what is there now, and we don't get any duplicates. It's always clean, and it's always exactly what's in AWS. One problem that we did encounter was ELBs. See, there's one API call to get back all of your ELBs, but it doesn't give you the instance health for it. So you have to call each ELB individually to get them. But unfortunately, Ozpost has so many ELBs, and Amazon throttle you at a few requests per second. Actually takes 2 minutes to cache all of the ELBs. And that's just for one environment. So that kind of sucks, but we're working on it. So linking. We use tags to link between stacks and instances and autoscale groups so that we don't have to use describe resources. Version photo we're using doesn't support ELB tags, so we actually have to go to the ELB, ask it for the first instance that it load balances, and then get the stack that it owns and put that as the stack that the ELB belongs to. And RDSs, we have to do that based on naming convention because we don't really have to either. So tasks. We use Celery Beats to do all of the asynchronous caching. It's kind of like cron, but for Celery. And we use Celery chains for the tasks. So what came up in that table before was 2 background tasks that we're going to run. So the tasks are all independent. They don't know what comes before them or what comes after them. They just know they've got a dictionary of inputs, and then they pass that dictionary of inputs into the next function. That they don't let all behind the scenes. The one problem that we have with the celery chains is that if the first one in the chain fails, celery doesn't automatically cancel all the other tasks. So we have a background job that's run with celery boots to come through and say, if the parents failed, then cancel this task. Celery won't run the job even if that doesn't happen. It'll just leave the task in a pending state forever, which isn't particularly helpful. So authentication, we're using an external authentication app because we really shouldn't be storing users and groups and stuff like that in a tool like Infracoders. So when a user logs in, we go away, authenticate them with that, and then we generate a token for them to do all of their put and post requests that come after that. So that way we don't have to store anything locally. And basically, we started building this back in late January. It's been about 6 months, and it's gotten to the state it's in now. We've still got plenty of more ideas for stuff to come, but obviously we can't demo the future. So we'll go back and we'll see how this is going. So the first job has succeeded, and cycle instances is still running. So this is what it looked like before, and now we can see that the tiers have gone yellow in the UI. That's because they have at least one instance that's healthy and at least one instance that is unhealthy. See, so these are the 2 new ones here that we said that we were going to create. They're not yet in service because they probably haven't passed their health checks yet. Hopefully they've finished bootstrapping. We'll take a look at them in a minute. Right now, I guess I'll show you some of the API while we wait. Can everybody see that? So these are the endpoints, the basic endpoints that we have available. I'll show you instances just because I think everybody kind of understands what instances are. This is going to take a while because it's getting back a few hundred instances. As you can see, it kind of looks like what you're expecting to get back from AWS, just there's a few tags and things that we've pulled out. So what we can do on the API is things like we can filter for instances with a running state. Okay, well, I might as well just try. We can also filter by multiple things. That came back quickly. See, so you can see that these are all web tier ones that are running. We can filter by anything that's on that list there, but that's kind of standard. Everybody should be able to do that. What we actually have that's pretty cool is we have a stats endpoint that gives us information like that. That's how many stats are currently running across all 3 environments in our post. Well, probably not all that useful, so let's group them down by account. Or we can do something like have a look at the versions of public code that's running on them in the test environment. So we can do a lot of auditing with this, and we can actually build dashboards and things that are kind of cool. Something I was asked to do not that long ago was find out how many instances we had in. So sorry, to help find out how many reserved instances we should probably try to get in the test environment. So that took only a matter of seconds using this API, whereas it would have taken a few minutes to even log into AWS to get that information. We also have an auditing capability for any actions that come through here. Every time somebody requests an action, we log it in here. So this is the one I just put through earlier. For a cycle, you can see action type, cycle instances, running on the Infracoders dev stack. That's my username. You can see that the status is still running. It's not done yet. But just like everything else, we can also run stats on that. So we can find out how many actions of different types have been run. We can also find out by user, so who's been doing what on the system. I was really hoping this demo would be done now. Did want to reverse it. Still not in service. And back to Michael maybe, and we'll see whether it's done at the end.
Yeah, absolutely. So Infracoders has helped the DDC in quite a few different ways. Firstly, it has empowered developers With more control of their application stacks, they're now able to trigger deployment into dev and test exactly the same method that happens in production, so by an auto-scaling group. They also have the ability to modify environmental configs and even update the underlying infrastructure without having to rely on any other teams within the department. It's also helped Susie, myself, and the rest of the systems team to be able to scale. So no longer are we involved in any of these activities unless absolutely necessary. By getting out of the critical path of several concurrent active projects, it's given us more time and flexibility to be able to concentrate on more medium and long-term objectives. Last but not least, it has provided transparency to all our application environments, to everyone in the department. So developers, operations, QA, BAs, architects no longer need to ponder about what type of infrastructure their applications are being deployed onto. All they need to do is hop on InfraView and have a look themselves. It reduces the information disparity, gets everyone on the same page to talk about real problems and real solutions. And with the API, the transparency provided can be leveraged by other teams for their own purposes. For example, I'm aware that our digital security team is looking to use our API to monitor all the new applications currently in development and what versions of software and operating system libraries they're currently using. And the intention is to preempt any potential security vulnerabilities before they hit our production environment. Our operations team is actively using the API to check for a specific application that the versions in dev, test, and prod are all aligned. And this gives them the added confidence that the relevant testing has been done on the right version of code and that there are no added surprises when deploying into production. So overall, the added transparency along with the API is definitely speeding up things and increasing collaboration within the department. Should we go back and have a look, Susie?
Probably on the file anyway.
That's the cloud.
Green.
Green's good.
And there's no instance of showing up, and that's probably why it's green. Yes! No more cores issues.
So for anyone that's interested in the challenges or technologies described today, we're also actively hiring, so please get in contact with Sunny, our HR consultant, or myself directly. Thanks a lot. Any questions?
There's no other questions. I was the first one to ask last time, so I'm sorry. Just really like my little question. How have you found Celery? We use it extensively and it eats all my RAM and my CPUs.
It's much better. It's much better now.
How have you found it?
I have found that I have had to clear out the queues on the testing stack a few times in the last few days for people. I have had to change the number of workers because the number of jobs got backed up at some point. It's been a lot of manual tweaking on that to try and figure out stuff. But it means that I don't have to figure out how to do, like, threading with Python is kind of a nightmare, so it's kind of better than that, I guess.
One thing we found out is be careful what you set up to expiry in both Celery and or even Q, because if it's diverge, you're having with it, you're going to have a bad file, basically. Like if Celery says keep all the queues for 24 hours, but Celery is like, no, it's fine, it's 5 minutes ago, I don't care about it anymore. Or even if it doesn't care, it keeps the whole queue for 24 hours, and then that is 12,000 queues on a single node. And you're like, what are you doing with running away, guys?
Yeah, we did have that when I accidentally had it, and I turned on callbacks for tasks because originally when we had the caching.
That's one that generates a new queue every time.
Yeah, we've got it set down at about an hour now for it to delete queues, except for the Celery one. So
Have it in queue, will do what you tell it to, and it won't do a lot of sanity checking.
yeah, oh, we've actually got Celery telling it to expire stuff rather than queue, but could do it either way.
You got
How open sourceable is it?
And the long stars post, I'm going to say.
Yeah, not too sure at this stage. I think we've got some company-specific stuff in it, like how we do CloudFormation and how we do tags and tiers and things like that. But we are purposing it for another project at the moment. So we are looking to make it a bit, take out some of the hard-coded variables and stuff like that. So maybe after we've done that, we'd have a better view of how open sourceable it is.
Quick question about the tips and tricks that you had. You said you couldn't use tagging for RDS instance. You had to use naming conventions. Could you elaborate?
We don't have we don't have tags on RDS instances.
Oh, so you don't use it?
Yeah.
I'm not too sure what's going on there.
What I told him he's the best.
Yeah. I think because we have quite a strict naming convention, it's possible to use tags or naming conventions. Either or would work.
Okay.
Yeah.
Cultural.
Have you guys looked at tools like Asgard, which Netflix open source, before you actually embark on this, or not really?
Yeah, some of the guys on our team did have a look at Asgard. I guess it depends on the platform you're building, really. Asgard is very generic AWS using auto-scale grids and so forth. What we've built is more like a internal PaaS, really, and it implements a lot of the internal controls that we need. So a lot of the security restrictions that we put in around security groups and trust stores and encryption and so forth. So we never really went down the Asgard path because it was just a bit too generic for us.
I like to talk about Asgard because we tried it. Asgard was great until CloudFormation came along. Asgard forces you into a certain mold and model of deployment. It does not interact very well with a lot of more recent features of CloudFormation, like rolling updates and update policies. It doesn't handle attaching and detaching DLDs, things like that. And then you find yourself in a situation where you're maintaining a separate tool while CloudFormation and the rest of the world goes on. So we are still removing Asgard from that environment.
Yeah. Last question.
For Javier.
Can you tell us more about the migration process? So you build this platform and you have all these capabilities for everyone to use, and I guess you have many projects you want to migrate into it. How did you go with that?
Yeah, sure. So really, so I gave a presentation earlier in the year about kind of the PaaS platform we built, and it was ready around November of last year when we did the whole whole AWS lift and shift project. And when it came online, there was a lot of active development going on, and all of those hopped onto the new application platform. And since then, all the development groups, every time they start a new project or revisit an existing asset, they would cloudify it to fit in the new PaaS model. So we started off with maybe 5 or so different applications. Now we're up to about 25 in prod. And I think I always thought that it'd be people doing actual migrations of assets and make them more cloudified. But what actually happened is new projects spin up, new assets get deployed, and the older ones tend to drift off. We're moving into more kind of microservices, so that kind of stuff is starting to happen. And yeah, we've just found that it's just been growing just organically like that, with assets dropping off and new ones replacing them.
All right. Thanks, Michael.